Welcome to the presentation of Agger, Gyala's solution for the protection of IT and OT infrastructures. Gyala was created in 2016 with the idea of going beyond the standard cybersecurity model, with a focus on reducing the use of qualified personnel within the Security Operations Center, and on reaching and managing all those infrastructures that cannot normally be connected to security centers, such as OT infrastructures. One of the critical points of the standard cybersecurity model is the reaction time with which operators are able to identify a threat, define what corrective actions to take, and then apply them. Normally, this can take several hours, whereas we have set ourselves the goal of being able to do this in real time. The technology was developed in the context of the National Military Research Plan and tested in collaboration with the Italian Army and Navy, and then brought into the civil sector, particularly in the critical infrastructure sector such as utilities, the merchant navy, the health sector, and more generally on industrial automation systems. Agger is an all-in-one platform for round-the-clock protection of IT and OT infrastructures, which uses detection system based on artificial intelligence algorithms to replace the use of specialized personnel and to simulate their behavior on all of the infrastructure's machines being protected. The ultimate goal is to have a more efficient, much faster, and constantly available cybersecurity system to increase the quality of service while reducing operational costs. The company's cybersecurity experts will therefore be relieved of monotonous monitoring work and instead be able to engage in post-incident analysis and strategic support for the company's security. In developing this technology, Gyala has focused on four main objectives. First and foremost, the identification of anomalous conditions, which is achieved through the analysis of network traffic and the analysis of all processes that run within the various computers, as well as through the acquisition of security logs already available in the infrastructure itself. The second is the creation of the behavioral model. That is, with the information collected, models are created that describe the dynamic behavior of the infrastructure and are used to identify deviations from what is being monitored in real time. The third is incident response. When an incident condition is identified, a series of actions are immediately applied according to a predefined rulebook, which are the exact actions an analyst would take when dealing with that specific incident in that operational context. The fourth is that it makes the data available for analysis. The system collects a large amount of the operating system's events, incidents and telemetry, which are made available for post-incident investigations, or even for carrying out pre-incident analyses of the infrastructure's operation. Thus it is able to correct any configuration or design errors in the infrastructure itself. These four main features have been achieved thanks to a set of software modules that have been fully developed by us, except the correlation system. The XDR agents that are installed on all client and server computers. The physical or virtual network probes for both IT and OT traffic. The correlation system is able to identify sequences of events of low severity that individually would not cause an incident condition, but together indicate a problem that must be addressed. The risk management tool that guides the user through the risk management process following the ISO 27500 standard. And the OT defense, which is able to perform active queries on all those devices that do not allow an agent to be installed on board. All these software modules are organized within an architecture that includes a centralized server, which contains the centralized components of the various software modules. The agents that are installed on all the client systems and servers for process monitoring. The physical or virtual probes that are installed at the various network points to ensure the complete monitoring of network traffic, and the interaction with the automation systems via the OT defense module. In addition, the Agger system is able to acquire pre-existing logs, such as those from firewalls, IAM and NACs, and other pre-existing security systems, and in turn become a provider of logs for external SIEM. Everything is governed through a web interface that allows operational administration, configuration, and incident management. The various software modules are therefore the XDR, with agents currently available for all Windows operating systems, from the XP 32-bit operating system onwards, as well as many legacy systems, all Linux platforms, macOS, and some versions of the Unix operating system. Network probes perform communications analysis from Layer 2 up to Layer 7, building behavioral models and analyzing the content of communications in real time. The risk management tool follows the ISO 27005 process. The correlation module analyzes all events for significant sequences. The OT defense actively checks PLCs, network equipment, and all physical devices, such as numerical control machines, or electromedical systems, that do not allow the agent to be installed on board. The centralized server, which can be installed on-premise or in a private cloud, and can also be delivered as software as service, performs active queries directed towards equipment such as PLCs, numerical control machines, electromedical equipment, routers, switches, and all physical devices that have network interfaces, and verifies the integrity and availability of the equipment. The network probe acquires, reconstructs, and analyzes traffic by creating patterns using machine learning algorithms, and monitors the content of communications as an intrusion detection, looking for specific patterns that may indicate an abnormal condition. The agent collects all security events and logs of both the operating system and applications, allowing the creation of reaction rules linked to application logics, and thus, goes beyond mere security by introducing resilience capabilities. It analyzes, enables, or blocks running processes, using various methodologies, including process behavior analysis, which involves the construction of models that describe the dynamic behavior of each process, which are subsequently used to understand whether the processes are deviating from the acquired model. It is capable of managing all removable devices, i.e., USB, SCSI, PCI, and everything else that can be hot-swapped on the various machines. It manages the local firewall, and can block specific network connections, rather than completely isolating the network machine, while continuing to control it through the agent itself. It performs change monitoring, which means that any type of change in the system configuration is identified and alerted. One special feature of Agger agents is that their behavior at both the detection and reaction level can be modified by configuring specific local rules. Each individual agent is thus able to have its own customized rules that determine which events it will monitor, and which actions will be executed as a response to the identified incident conditions. However, all types of events generated by the agents, probes, OT monitoring systems, and acquired logs reach the centralized server, which is thus able to correlate them, and if necessary, decide to apply further corrective actions. This is achieved by the centralized server configuration rules, which allow further actions to be controlled in addition to those already applied by the agents themselves on the individual machines. As mentioned, this technology, which originated in the military, was tested for 2 months on board the Navy's military frigates, in collaboration with the Italian Navy, and was subsequently tested in the same way by the cybersecurity group of the Italian Army's Communications Department, and is currently being adopted by the Italian Armed Forces. In particular, on the ship, the system is deployed on the entire ship management system using agents on all the human managing interfaces of the infrastructure, and on the SCADA servers, installing IT and OT probes on both the supervision and automation networks, and installing an Agger server to activate the control system for actively checking all the onboard PLCs. This technology has since been taken to the civil level, and is currently installed, by way of example, in power stations, hospitals, hospital facilities, military ships, and manufacturing and production companies. The most significant results are certainly related to the efficiency gains that this system introduces, through the reduction in the number of operators required from the 5 operators essential to cover the H24 shift, to a single operator, whose task is to control and manage the post-incident phases. The other important element to be emphasized is the reaction speed, which, thanks to our software, is on average reduced to 0, compared to the time normally required by a human user, which can take up to several hours. Here we can see Agger's main screen, which shows the number of managed endpoints with the various operational statuses, allowing the immediate identification of those with ongoing incidents. The number of active incidents categorized by type. The classification of all executables, which summarizes the analysis of each binary file containing operating code that the agent executes as soon as it is installed, together with the collection of all configurations, files such as exe, com, system, DLL, bin, and everything that on Linux, Mac, and Unix is marked as executable are classified. All these files are analyzed and classified, identifying the trusted ones, which will be left running, and the malicious ones, which, of course, will be instantly blocked. Finally, there is a graph showing the incident trends. The generated ones are in yellow, the managed ones are in green, and the ones still to be managed are in red. This screen shows the asset inventory. That is the list of all machines in the infrastructure that have an agent, classified by type of operating system. A customized tag can be added to each machine in order to create groups and subgroups to facilitate their management. They can, for example, be grouped according to the type of services, or the physical location where they are installed, or they can follow logical groupings specific to the organization to which they belong. Each of these machines provides a detailed tab, which contains basic machine informations such as operating system, hardware type, incident list, collected telemetry amount, and machine on or off availability. Through this tab, it is possible to issue commands to multiple machines at the same time. For example, enable containment means isolating the machine from the network. Rescan file system starts a new system scan. The services status, checking those that are active and deactivated with the possibility of modifying them. In the real-time process analysis, we can see the list of processes running in real time, with the available detail of each single process. In networking, there are main networking parameters, such as host control, etc., and routing tables. In this screen, it is possible not only to view, but also to modify the rules of the local firewall of the machine. The complete list of executables can be checked and instantly interacted with, for example by deleting them, modifying them, or adding them to a trusted list, and thus allowing them to be executed. The same can be done for verified systems, or those still in the verification phase. Here you can scan file system content and capture files remotely. All the information collected is monitored constantly by the system, which immediately generates an incident as soon as it identifies a sufficiently severe anomalous condition, or a sequence of less severe anomalies. The table of incidents groups the different events that contributed to its generation, and by clicking on the individual incident it is possible to access the details of the individual events, to get a clear picture of the attack pattern. The right-hand side of the screen shows which detection rules centralized on the server, or localized on the agent detected the anomalous condition, and the reaction actions that were automatically applied. In the context of an incident, it is possible to interact directly with the operating system by giving specific commands, such as blocking the connection, killing the process, or interacting with devices and users. In the network section, the network traffic can be analyzed in real time, as well as the behavioral models that have been built with it. Above the graph is a timeline that shows various snapshots of the model, which provides an understanding of how it has evolved over time. The graph can be navigated at both the node and link level, and provides drill-down access to all network session details. In the configuration area, both the centralized rules and the rules running within each individual agent can be customized. This is done by filling in a form, in which parameters are defined to determine the anomalous condition to be identified, the severity of the condition, and what corrective actions, if any, should be applied. The sequence of reactions can be as long and complex as required, e.g., a process can be killed, a connection can be blocked, a machine can be isolated or re-networked, a device list can be closed, a physical device can be disabled, a service can be dumped, a process can be enabled, an environment can be requested, a configuration control can be forced, and possibly other rules can be triggered, according to changes made to some parameters within a configuration. Any type of file operation can be enabled, for example copying, deleting, downloading, searching within the file system tree, or writing a file. Other possible actions are changing the status of the firewall, requesting all historical built connections of that machine's models, disabling all users from a machine, giving manual instructions to an operator, so that they can follow a manual operation process and therefore solve the problem. It also identifies a process depending on a network connection, requests all processes and all network connections active at the time the incident is triggered, requests the process list, the real-time connection list, the service list, executes a shell command, i.e., any type of command within that machine, and also starts or stops processes and services or modifies the registry of the Windows machines. At the OT level, that is at the operational technologies asset level, a list of controlled devices for which all the details of the information these devices display, through the communication interfaces they publish on the network, is available. Each device is constantly monitored for availability and integrity. In the event that it can no longer be reached, or responds with different parameters than expected, an incident will be generated along with all the relevant responses according to the rules described above. The OT defense system enables network scans to recognize and identify OT devices and collect specific detailed information. Thanks for your attention. For information on our product, please visit www.gyala.com or contact us directly by email at marketing@gyala.com. Thanks.